Hello, my name is Chris Harding, and I'm a administrator as well as founder of Beginning OpenFOAM on Facebook. And what Beginning OpenFOAM is all about is beginners collected to help other beginners. And they do try to solve problems at the same time. And what's nice about it is, although CFD online exists and there's answers to most problems there, what's nice about Facebook is people can get information in their lead and then they can comment and they can help out. So it's more active in my opinion. And when I was learning OpenFOAM by doing the 3 week series, I thought that something like that would be beneficial. So I pretty much opened it and started it and then built it as I was doing the 3 week series. And now I've had Dr. Gohill's online training as well, and I'm working through the extended training that comes along with his videos and his tutorials. And I decided that, I wanted to learn point H and pointField.H, excuse me, pointField.H, and that method of entering vertices because I saw a member at the beginning open foam group on Facebook who had posted a question about the help with it, and it's not something I was familiar with. So I thought, well, I want to learn a little CodeStream anyway, so why not start out with something that's probably a little more basic. And so what I did was I wanted to specify fewer points. And that's what I liked about pointStream is that it basically grew in the z direction from all the points that were in the x and y plane and grew it in the z direction. So you had to specify a person specify half the points and get the same geometry. So I thought, can I not specify all the y points, grow it in the y direction, and then grow it in the z direction, all the points? And it's programmatically, it doesn't seem like it should be that difficult, but you got to get all the hexes and all the faces to match up. And block mesh dictionary, you got to do that. And block mesh is really for more simplified geometry, anyways. So I've decided to do an answer to a challenge I created on OpenFOAM, beginning OpenFOAM on Facebook, and the challenge was, after I did it, was to grow 2 points in the y direction by 2 points, and then grow all the points in the z direction to create a cavity with a moving lid and three fixed walls and two-dimensional. And so you don't want to grow it too far in the z direction. You only want to mesh one block. And so this is something that I want to start with right now. And the first thing that you really need to do, and I've already done it, is to create a cavity tutorial or copy the cavity tutorial from tutorials. And to give you an idea about what tutorials are, then one second, is right here is I found the tutorials. And the way you can get here is to type TUT and it'll go to tutorials, and then I know that the cavity is underneath the incompressible anicofoam, but you can also grep for it if you want to, and then just copy the grep information to your command line, then change directories to that. And so this is where I wanted to copy the actual file or the directory of the cavity tutorial, because as you can see here, cavity is a part of this tutorial, and it's an icofoam, which is a transient solver. So which is what I'm going to use for this purpose. So um, what I wanted to do was to copy this cavity file. So what I did was simply highlight the information here and copy it, and then put my cursor in my next one, said copy R, and we're not going to copy it, but and then said paste. It's a good way to, some people are quick typers, I'm not, and my spelling's horrible. So the thing is that copy and paste works for me more often, but I'm not going to do this because this will copy cavity clip and also other cavity files and all run and all clean, and I don't want to use those. So I copied it, and then what I did is I actually I copied it, and then I removed those files. So I have a cavity file with the cavity in it. And it's important to have this file because this is the file that we're going to go off of. Um, it's got all the setup that's needed, and it's a good idea to find a file that's as closest to what you need in order to set up your case, which is kind of what we're doing here. So I have a cavity file, and I'm going to rename this cavity file, the original. I'm going to rename it by using the move command, and we're going to rename it to, we're going to call this point field. Okay, so now my cavity file is named point field, and so we're going to change directly to point field. And I try to follow the OpenFOAM style of naming things so that I get used to it. So when I'm typing out commands and things of that nature, so I try to follow that style to help me out. And we're going to change directory to point field. And what we're going to do is we're going to go into the cavity directory, and we're going to leave this as cavity. But as you can see, it has a zero constant system folder, which is, I'm using version 7, so which is common amongst version 7 and version 5, I think from version 3 forward. But we're going to block mesh this, and the way that you can find out whether or not you want to use block mesh or snappy hex mesh is if it has a block mesh dictionary file or a snappy hex dictionary file, and each one of them will be in the system folder. So I like Genie. I discovered that from Dr. Gohill, and it's a fascinating API for programming. It gives you the line numbers nicely. I know others will too, but you don't have to set it up, it does it automatically. And so I like Genie, and we're going to go into system and just see if there's a block mesh folder. There is. So the block mesh folder, and one second, let me do that again. Um, Actually, do I need to? No, I don't. Okay, so the block mesh folder over here, as you can see, and I've already changed it. I actually added these 0, 1, 2, 3, 4, 5, 6, and 7. As you can see, it starts out the origin with 0, 0, 0. And I find typically that that's for what I'm about ready to do, that's a good way to start out. And then you grow it in the directions that you need to grow it. You can start out with it at negative 0.05 and then go to 0.05. But then the origin will be in the center. And the way I'm doing it, there will not be a line for the origin. So I think that, starting out with the origin at 0, 0, 0 is a good way to start. And then name it. And when you name it in pointField.H, using pointField.H, we'll find that the points don't necessarily work out, so we're going to figure out a way to print that. But anyways, it has a block mesh dictionary file, and we're going to run block mesh, and which it created a block. So as you can see here, the number of cells is 400, and we're actually going from 20 in the x direction, 20 in the y direction. 20 times 20 is 400. The number of faces is 1640, and the number of points is 882. And um, it gives you some other information with the when you create the block mesh, but some information that we're going to use in the future that we're going to include in our programming is where the points are. Point 0, what is the coordinates? Point 1, what is the coordinates? And we're going to print that out right here so that we'll be able to see that, so that we'll be able to draw out our cavity or draw out our double cavity or whatever we need to draw out that we're trying to grow and mesh. And so anyways, um, now I'm going to run parafoam, or it's got to be a capital F, block, to take a look at the block. And you can go to the manual to get the idea of how the block is created, but I actually prefer this hands-on method, and it's, I mean, the manual for me, can be a little hard to understand sometimes. So here's the block. And as you can see, point 0 is in the back. And then it grows point 1 right here. It grows point 1 in the z direction. And that's going to point 4. As you can see here, point 4 is the first place it starts growing in the z direction. And then point 1 goes to point 5. And if you look here, point 1 is 1, 0, 0, and point 5 is 1, 0, 0.1. Everything's the same, except it grew in the z direction. And that's what's going to happen in the point field as well. And we're going to have certain points, but they won't come out, for me anyways. You can set it up differently, but for me, the way I did it, they don't come out nice and organized necessarily like this, or off a little bit, and you'll see that. But that's the reason why I print out the point information, so that I can actually draw my own block and then get the hex, the block hex, and then the faces. So now what we're going to do, since we've taken a look at this, and you can see here that the top is the moving wall. And if you look at the moving wall from the inside, and that would be here, and go clockwise, which is this direction, you get 3762 as the actual, you're looking from the inside of the block towards the wall, looking outside, and then you do clockwise direction, and we're going to start at 3, and it's 3762. But you could start at 2 and go 2376. And for example, it's 3762 here, but if you started out at 2, it would actually go to 2376. 2376. So you don't always have to start out. I like to start out from the lower number, try to keep it consistent. But that's something I do. And then if you look at the fixed wall here, because we have one moving wall and 1, 2, 3 fixed walls. If you look at the fixed wall here, you got 2, 6, 5, 1. And you can see here that's one of the walls. 2, 6, 5, 1. And then if you look at the bottom one and go clockwise, we're looking from the inside out and go clockwise. It's 0, 1, 5, 4. And you got 0, 1, 5, 4. They said 1, 5, 0, 4, 0. And that's still clockwise, as you can see here. And then if you look at the other side and fixed wall, we go from 0473. And that's another number, 0473. And remember, we're going from the inside and we're looking out. And this is with the 0 in its original position. And you can move in another position, do it, but it gets a little more confusing. But when we do the hex block, if we look here, we want to look at the back wall and the front wall for the hex block, and the in between there, because we're creating a block, and that's where the lines here from the z direction is creating the actual cavity with a moving top and fixed walls. And if you look at the front and back, which are set to empty, so we can have two-dimensional, because this is only going to be 1.1 in length, and it's going to be one block in as far as one cell, rather, as far as the actual number of cells that's going over here. And that will make this a two-dimensional flow, because OpenFOAM prefers, well, I shouldn't say prefer, they can do two-dimensional, but three-dimensional is what it's set up for in the block mesh. So you have to make a three-dimensional, but make it small, and then set it to empty for those walls. And if you look here, if you go with this wall, and we're supposed to look from the inside out, right? And we're supposed to go clockwise. And so if we look for the faces, because these are faces. So if we look here at inside out, and we go 0, 3, 2, 1, you can see here that it comes out to be 0, 3, 2, 1 here. So we're looking from the inside, because we're inside and we're looking towards the out, and this is with the 0 in the correct position. I mean, in its design position and specified position. And so the thing is we look at the next wall here. We would go 5, 4, 7, 6, and if we look here, that's not how this goes. This doesn't go 5, 4, 7, 6. This goes 5, 6, or 5, 6, 7, 4. It goes 5, 6, 7, 4. It goes 5, 4, 4, 5, 6, 7 here, but it can also go 5, 6, 7, 4. And I didn't start out with the lowest number that time. But the thing is that why did that happen? And it's counterclockwise. That's because we're not looking from inside out. So to turn it, you have to turn it around, and then like we looked at the back wall inside out, now we're looking at the front wall inside out. And if we look at the front wall inside out, then we have 4, 6, 4, 5, 6, 7. You got 4, 5, 6, 7. So that's 4, 5, 6, 7. Because now we're looking on the inside out. And that's going to be very important when you're creating geometry. And it's especially important when you're creating a cylinder in 2 dimension. And especially if you use the tutorial setup of a half of a cylinder and flowing over something like a culvert on a bridge or something like that when. But if you have flow around the cylinder, you want to mirror that in the Y direction, then Z direction. It's a lot of points, it's a lot of blocks, and then this can get quite complicated. But here we only have a cavity, so it should be quite easy to mirror it. Well, one of the things that I ran into as a problem is I didn't know how codeStream worked, because this is the first time I've ever used codeStream except for the very basic situation, and I'm going to show you that right now. But before we do that, and this is going to be a long tutorial, um, and you can actually stop it at certain sections wherever you want to, and then start at other sections. And so this is going to be somewhat of a long tutorial because I want to go through what I did to learn this process, and I figure other people will probably go through a similar process. So the thing is, what we have here is we have a cavity, right? So if we want to mirror a cavity in the Z direction, how would we do that first? So we're going to specify all the X and Y points in the XY plane. Well, not all of them, but we're going to specify 4 of them. And we're going to then grow those 4 points in the Z direction. How can we do that? And there is, believe it or not, there is a pointH tutorial or pointField.H tutorial. And let me take a look at that right now. Let's go ahead and close out the block. And what we're going to do here is we're going to go to the tutorial file, which is up here, and we're going to go toot, and that typing in toot's an alias, it'll take us to tutorial files that are built in and distributed with OpenFOAM. And we're going to do grep r pointField.H. And you can see here that one file popped up, and it's basic potential, cylinder, and block mesh. So this is the pointH field for the cylinder, and you're going to see here, we're going to go ahead and run this, but we want to copy this dictionary. So we're not going to run this. Actually, you know what? I'm going to copy it so that we can run it, so that we can actually see what it looks like with a lot of blocks. That's a, it's not a directory, it's a file. Well, one second. I know I'll get this here in a second. Copy. Oh, I forgot R. No such file or directory. Well, let's go up here and see. One second. I've forgotten how to do this. So I'm going to pause for a second, figure this out, and then come back. So I figured out what I did wrong. And what I did wrong was I was actually trying to copy basic potential foam cylinder system block mesh dictionary to to my new directory, and it was giving me file not found, not a directory error, because I needed to go from opt and I changed to the actual um, directory that has the cylinder, which is this. So if you change to a directory that has it, and you copy this, and then you go down here, you say and you change to remember we created a point field directory, so that's where I want to copy it to, and copy R, so it's, I believe that's for recursive, and goes through the file folders. It needs to be specified for directories, and then dot for here, and oh, I put the command in wrong, like I told you I can't type. So okay, so let's see. Now we have cavity in the cylinder. So let's go into the cylinder, change directory to the cylinder, and you can see here that cylinder doesn't have a constant folder, and this is version 7. So that can be a little bit odd, because personally, I'm used to seeing a constant folder. So let's go ahead and run this, because I want you to see the number of blocks that are created for the cylinder, number of times you have to specify the faces going clockwise and then when you switch it and going from one direction to another to get your faces in your block mesh dictionary, the rules associated with that, which you can find from the user manual, or just open a cavity tutorial and run it, and then open up the actual parafoam block and then look at it according to the block mesh dictionary and get your bearings. But here there's no constant folder, there's only a zero and system folder. So let's see what's going on here. Let's see if it's block mesh, or if it's, so by a easy way to do that is to type, you can do ls tree, which is really easy, or you can just type this, and then if block mesh pops up, dictionary pops up, then it has one. And as you can see over here in this block mesh dictionary, this is now different from, you can see vertices, and the first thing that's done is they put a pound codes hashtag codeStream, and then they actually do code include, and they say to include the point.H field, and then they do code, and then they say the point field. In the block, in the situation associated with the cylinder, uh, XY plane, they specified a total of 19 points that go from 0 to 18, and we're going to see that here in a second. We can't view it right now through parafoam, but this will run. And I just want to explain this part right here real quick, which caught my attention. Label SZ point size. What this does is it actually sets SZ to the point size, and the point size is 19. So it puts SZ at the points of 19. Points set size 2 times SZ. Because the new size now, because this Z is going to grow in the Z direction from the XY plane in the Z direction. So it's going to double the points. All the points is going to become doubled. So this is specifying what the new size is going to be. And then points, for label I equals 0, and this is how you, instead of say integer or anything like that, in CodeStream use label to declare label I equals 0, and then I is less than SZ, I plus plus, and then it associates an address with the points, and then it says, okay, I plus SZ, so it starts out at 0 because of C++, and 0 and SZ, we have SZ, which is a point size, which is 19, so the 19th point is going to be point, and then this is for point X, point Y, and negative point Z, because it's growing in the Z direction. And as you can see, they started out here with a Z direction of negative 0.5 instead of an origin. I prefer to start out the origin and then grow it, but they're going to the negative of this value, and which is the negative of that is going to be positive 0.5. So it's going to be 1 in length. It's going to be a pretty good size Z direction. But the thing is that they're only putting one cell in that direction, and so it looks more three-dimensional, but it has one cell. Most people make it smaller, make it smaller so that so that people know and they remember that it's only doing 2D simulation. And so, anyways, they specify the points here, and what they did is they specified all the points in the X and Y, well, not all points, but they specified certain points in the X and Y plane, and then they grow it, they mirror it in the Z direction, and they really mirror it here because they're going the opposite of what they specified for Z, and then they have this command OS, and I don't know if that stands for operating system or points. I tried to do a quick search on it, and I didn't find anything really to explain it. And that was one of the problems that I had when I was trying to figure out how to do grow in the Y direction and grow in the Z direction. I was getting errors, and I didn't know if it was because I needed to specify OS after specifying the Y points, or declare OS after specifying the Y, not declare it, but put values in OS after specifying the Y points. But we'll come to that later. And so I want to go ahead and run this block mesh dictionary file. And you can see here it takes a lot more time, but they specified 2020, and then they got the patches, they got the bounding box, they have the number of cells is 2000, and that's because there's a lot of blocks here. And as you can see, there's a lot of blocks here, so each of them have cells in certain directions, and the total for all the cells comes out to be about 2000. So let's go ahead and take a look at this now that we created block mesh. Let's go parafoam, just so you get an idea how complicated it can be and how much can help once you figure it out. Parafoam block. Remember here in the block mesh dictionary, it's still two-dimensional, but the code grows it into a three-dimensional geometry. And I forgot to specify negative. Para. This is the number of blocks. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. And if you mirror this grow it in the Y direction first and then in the Z direction so that you have a cylinder and you can have flow going through here over the cylinder. And the reason why you want so many blocks or around the cylinder if you mirror it, the reason why you want so many blocks because this is going to be a curve. And it's going to be because it's going to be a cylinder, the end of a cylinder, or somewhere in the middle of the cylinder cut in a 2D plane. And it's going to be a curve, and the mesh is going to go out in this direction. And the mesh has to match up with this block. All the coordinates, if there was a line that came down through here and then landed right here, then this block mesh would want to continue on with that line in that position. And I'll show you what the mesh looks like. I think I'll show you what the mesh looks like. Let me see. First, let me see. I wanted to show you that a constant folder was created. Let's take a look at constant folder and show what's inside here. And there's polymesh. And then let's take a look at that because it's saying through the creation that it actually has created a mesh. And ParaFoam gave me, and I don't have a mesh. So let me see. There we go. For some odd reason it wasn't loading. I don't want you. Haven't ran it yet. Solid. This is what the mesh looks like. So you can see here if you zoom in and you turn it a little bit, this line right here lines up with this line that goes up. And totally, there's, what was it, 2,000 cells here. But that's what this looks like as a mesh. And you have to have these lines match up. And this line right here matches up with this line that goes this direction. So this is a block. Remember, this is a block, this is a block, this is a block, this is a block, this is a block. There was a block here, a block here, a block here, and a block here. And your meshes have to match up. And that's really difficult to do when you're first learning this. So multiple blocks is really difficult, and what we're doing is we're starting at something very simple. And if I can, I hope to be able to do the cylinder sometime in the future. And then I'll make a tutorial for that. If I don't make a tutorial, you know that I didn't actually succeed. So, but this is my first tutorial, so it depends on how people respond. If they say it was too long and too boring, then I probably won't make any more tutorials, or I'll try to switch it, make it a little better, make them shorter. But this has to be a long tutorial because I want you to go through the process as I went through the process to learn. And I think that, but I'm not going to go through the entire process. It took me a while to do this. Took me hours. So I'm not going to go through the entire process, but I'm going to go through some of the process. So now we've seen what it looks like with a lot of blocks, and we've seen what the mesh looks like. Now what we're going to do is we're going to go to the cavity, and we're going to look at the mesh there. Run block mesh. And this is what the mesh looks like, and they're identical, they're mirrored. And as you can see, it's a small direction in the Z direction. There's one cell, and then there's 20 lines in the Y direction and 20 lines in the Z direction. So it's 20 times 20 is 400 cells. There's only 400 cells here. It's a very coarse mesh. And if you take a look at this surface with edges, then you can see that it's a very coarse mesh, and this is more what the cells look like. There's 20 lines in this direction and 20 lines in this direction, so 400 total. And but anyways, that's what the actual mesh looks like that we're going to be doing. But as I said, what we're going to do first is we're going to first mirror or grow this plane right here into a new plane, creating a three-dimensional geometry that only has a cell in one direction. And that's what we're going to do. That's what we're going to finish with. Actually, that's what we're going to finish with in this tutorial. And then I'll make another tutorial where I grow it in the Y direction, and then I grow it in the Z direction. And so anyways, so what we're going to do is first, we know where there's a pointField.H file. Close out of this. It's in the cylinder. All right. You can see it has dynamic code that was created, so that's a .h file. So let's open Genie, and we're going to copy this. If I type it, it's going to take me forever. We're going to copy from the vertices down to where the vertices ends, which is right there. And that's all we're going to need. And we're going to go to now we have this other block mesh that's open here. So this one's for the cylinder, and this one's for the cavity. So the vertices look like this in the cavity. We're going to keep these vertices, but just so we have something to look at, and but we're going to comment them out so that they don't mess with the code. Actually, I tell you what I'm going to do is I'm going to comment out this whole section. C++, that's how you comment out the whole field. And paste this in. We want it to be 1 to equal 1 meter. So we're going to change this to 1. We don't need all these points. We only need 4 points because we're specifying a box. We're basically creating a two-dimensional box with these 4 points. And so we only need 4 points, so we go from 0 to 3. And point 0 is same as here. We'll go ahead and put this parentheses back. 1 second, I'll be right back. I got to take a break. Okay, it took me a little while longer than I expected. My apologies. I forgot where I was at. So what I'm going to do, I have a general idea, is I was talking about, that the dynamic code exists here. We know that the point H is here. So we copied over the information, and we have, basically we're building a cavity in the z direction. So we're only going to grow it in the z direction. And we're going to use these points right here. 0, 0, 0, 1, 0, 0, 0, 1, 0, so 0, 0, 0, 1, 0, 0, 1, 1, 0, and 0, 1, 0. And we're going to grow these in the z direction. But before we do this, what I want to do, so what we want to do is grow this in the z direction. And that's what's happening here. So we specified point 0 as 0, 0, 0. It's just like the cavity that we saw earlier. Um, but the thing is, it's in point field H form. And then 1, 0, 0, just like this. And then 1, 1, 0, and then 0, 1, 0. So we specified 4 points, because we're not growing it in the y direction. We're only growing it in the z direction. And then this is going to grow it in the z direction. So what we want here is, we're not going to say negative point z. We're going to say point z plus 0.1 plus 0.1. And we're going to say that that's what we're going to grow it in the z direction, because we want to grow in the z direction of 0.1. So the 0, 0, 0 will be in the back, and the front will be the new number, whatever that might be. To figure out what that number might be, then what we're going to do, we're going to create a for loop here. info command to send something to the screen. What we want to do here is print out the points. So let's figure out how to do that. So we're here and we're in this cavity. This is a new cavity block mesh file. We're going to save this. Be careful, almost hit the X. And we're going to go down here and we're going to run this. So we get an error. And the error we get, and we can see here that the error we get is we get too many points. And why did we get too many points? Because you can see here it starts doing it, but it has a lot of these here at plus 180, and then it says non-planar blocks and gives information from OpenFOAM, which is to me is quite cryptic. But what I did is I noticed that there's a lot more points than I needed. So where did I make a mistake? I made a mistake and I did not change the actual size and the number of points. So I got a lot of points and they didn't have corresponding information. So so I had a problem. So I only have 4 points, and it's probably going to give me an error for a while because I got to create the faces and I kind of create the blocks. But I want to see if the points print out correctly. So I'm going to run this again, or this one rather. First I got to save this by Control S on Genie. Then it actually built. And you can see here that this is point 0. Point 0 is 0, 0, 0. Point 1 is 1, 0, 0. Point 2 is 1, 1, 0. Point 3 is 0, 1, 0. Those are the ones we specified. And then remember it's 0 plus SZ. And SZ is 4. So it's good because it's the size of the points, which is 4. We specified 4 of them, which are over here. So it's going to be point 4 is going to be the same as point 0, but it grows 1 point or point 1 in the z direction. So point 4 is 0, 0, 0.1, 0, 0, 0. Remember the cavity when it grew in the z direction? And then point 5 is going to be the same as point 1, but it's going to grow in the z direction as well. Where the point 5 here is the same as point 2, or this is 0.6. The 0.5 is going to be the same as 0.1. It's going to grow in the z direction by 0.1. 0.6 is the same as 0.2, so it's going to grow. And 0.7 is the same as 0.3. So if you draw a block, and now I suggest that you draw this out on paper and draw these points out. You know what the square looks like. But what we're going to do now is we're going to take a look at it. So we're going to go parafoam block. Because it matched from what they specified for faces and blocks, we get a block. Point 0 is here, and what point is this right here? Remember, 0 corresponded to when it's I plus SZ. SZ is 4, so when I is 0, it's going to be 4. So this, now if we look at this, if we look at the block, we turn this towards us, we got 0, 1, 2, 3, and then we got 4, 5, 6, 7. And that's what the actual block mesh dictionary says as well. As you can see here, we have 0, 1, 2, 3, 4, 5, 6, 7, 20, 20, and gradient is 1, 1, and 1. Meaning that, and that means if you have a non-uniform mesh where if you have a small cell starting with and it becomes a big cell at the end, or you start with a big cell and it ends with a small cell. And so the thing is, the block was actually created. And I actually didn't know if these were going to match up perfectly. But as you can see, what I did though, and it's very useful, is I put an info statement in there for this right here. And I believe that as you'll see when we grow it in the y direction, that's the reason why this actually worked. It's because we're only growing in the z direction, so the points actually correspond correctly. But when you grow it in the y direction, the points don't actually line up the same way as this does. And that's going to be the next tutorial. So to review, what we did is we wanted to take a look at the cavity according to how the cavity is set up originally in the tutorials, the distributed tutorials. And we took a look at the cavity. We took a look at how the blocks were created, how the faces were created, and we got an idea about that. And then we went to take a look at the cylinder in order to get an idea about pointField.H and also the fact about number of blocks that's available in cylinders that makes it more complicated to specify, because we would have to specify in each one of these areas down here. It wouldn't be moving wall, it would be inlet and outlet, and then fixed walls, and then front and back. And the thing is that we would have to specify the blocks that you remember that are on the cylinder, and we'll take a look at that again, and then we'll finish this tutorial. So to give you an idea of what the cylinder looks like, we'll go ahead and close out of this, and remember that's a lot of blocks. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks that we have to specify. And on each one of these, you got to look from the inside and then specify the numbers. And for each block, and that takes up a lot. It takes a lot of time, and you have to be very, very careful. And where you specify that, if you remember, is in the block mesh dictionary, which is right here, and this is for a cavity. But if we go into cylinder, then you can see that this is a lot more blocks that have to be specified. There was only one for the cavity that we created. A lot more edges because there's arcs, and a lot more faces, um, down, right, up, left, cylinder is what they named them. And there's a lot more face blocks or faces that you have to specify in here. And you got to be very particular about how you do that and be very careful. And that's one thing that this tutorial and hopefully other tutorials are going to help people understand. By going through this process, they'll have to actually and do it on your own. Don't just watch the video. Now do it on your own. And then refer to my video in places where or watch the video again. And remember, this is my first tutorial. Hopefully I get better. But the thing is go ahead now and grow yours in the Z direction by changing the pointField.H. You don't have to run it. If you want to run it, you can. But you don't have to run it. Right now we're just working on blocks and block mesh and building geometry using blocks by specifying fewer points. So thank you, and you have a nice day.